Littleton Coin Company is ringing in the holiday season with daily deals. Visit littletoncoin.com for at least 15% off select products now through November 28th. Save on your favorite coins, such as Morgan Silver Dollars, Kennedy Half Dollars, commemorative quarters, and much more. But hurry, each day offers a new deal you don't want to miss. Visit us now at littletoncoin.com. That's littletoncoin.com. Littleton Coin Company, serving collectors since 1945.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime, Series 26, Episode 109, for broadcast on the 11th of September 2023. Coming up on SpaceTime, have they finally found Planet X? Japan's XRISM Space Telescope launches into orbit, and discovery of our own local baryonic acoustic oscillation. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers in Japan have found possible evidence of an Earth-like planet orbiting in the Kuiper Belt. The findings, reported in the Astronomical Journal and on the pre-press physics website archive.org, are based on the discovery of unusual orbits for several Kuiper Belt objects and suggest a large Earth-sized planet orbiting around 500 astronomical units out from the Sun. An astronomical unit is the average distance between the Sun and the Earth, roughly 150 million kilometres or 8.3 light minutes. The Kuiper Belt is a ring of comets, icy worlds and frozen debris circling the Sun out beyond the orbit of Neptune, which orbits some 30 astronomical units out from the Sun. The dwarf planets Pluto and Charon are probably the best known Kuiper Belt objects. The new study's authors, Patrick Stafia-Lakakwa from Kindai University and Takashi Ito from the National Astronomical Observatory of Japan, described the orbital properties of trans-Neptunian objects, which appear to be consistent with gravitational perturbations that would have been caused by a planet not much bigger than the Earth orbiting among them. They also found a significant number of Kuiper Belt objects at high inclination orbits. Intrigued by their findings, follow-up computer simulations designed to explain their observations showed that the most likely explanation was a relatively large Kuiper Belt object, such as a planet. The simulations also showed that such a planet, if it exists, would have a mass of between 1.5 and 3 times that of the Earth, an inclination of approximately 30 degrees to the ecliptic, that is the plane where the planets roughly orbit the Sun, and an orbit that would take the planet between 250 and 500 astronomical units out from the Sun. The new findings are just the latest effort in an ongoing search for a so-called Planet 9, sometimes referred to as Planet X. But what makes this new effort so interesting is that the suspected planet's orbiting much closer in than what previous studies have suggested. The first solid hints of a possible Planet X or Planet 9 came to light over a decade ago when astronomers were looking for objects which could pose a threat to the New Horizons spacecraft, which at that time was on a mission to study Pluto and the Kuiper Belt. As they undertook their surveys, astronomers noticed some unusual gravitational perturbations in the orbits of 13 Kuiper Belt objects thought to have been caused by interactions with a yet-to-be-discovered massive planet-sized body. Then, careful calculations of the orbit of a Kuiper Belt object 2012 VP113 by planet hunters in 2014 led to the detection of similarities in the orbits of several other distant Kuiper Belt objects. And it resulted in a new hypothesis postulating the possible existence of an unknown Planet X or Planet 9. Now, based on the earlier observations, the undiscovered world would be up to 4 times the size of the Earth and around 9 times Earth's mass. Now, that's a lot bigger what's being proposed now. Also, the orbit was very different too. It was on a highly elongated orbit around the Sun, estimated to last at least 15,000 Earth years. If it exists, the mysterious Planet X could be an interstellar rogue planet captured by the Sun's gravitational pull, or it could be a planet that was stolen by the Sun's gravity from a neighbouring star system early in the history of the solar system, when the Sun was just leaving its stellar nursery. Another option is that there are several models of planetary migration within the solar system which suggest that as Jupiter and Saturn migrated out to their current orbital positions, their gravitational perturbations caused Neptune and Uranus to also move outwards, in the process swapping their orbital positions and flinging a third ice giant, which was part of the group, out into the Kuiper Belt or possibly even beyond into interstellar space as a rogue planet. Oh, and as for the indecision between Planet X and Planet 9, well, the first ideas of a Planet X in the Kuiper Belt came at a time when Pluto was still considered a fully fledged planet, before it was demoted to dwarf planet status. And so this Kuiper Belt world would have been a 10th planet, a Planet X. This is SpaceTime. Still to come, Japan's XRISM Space Telescope launches into orbit, and discovery of our own local baryonic acoustic oscillation. All that and more still to come on SpaceTime. A powerful new Japanese X-ray telescope has just blasted into orbit. The X-ray imaging and spectroscopy mission XRISM was launched aboard an H-2A rocket from the Tanegashima Space Center in southern Japan.
All systems are go. The main engine ignition. Solid boosters ignited. Liftoff. We have a liftoff of the H-2A launch vehicle number 47 from JAXA Tanegashima Space Center at 8:42 and 11 seconds a.m. on September 7th, Japan Standard Time. The H-2A is now flying above the Pacific Ocean to the east.
Led by JAXA, the Japan Aerospace Exploration Agency, in collaboration with NASA and the European Space Agency, the 2,300-kilogram spacecraft was placed into a 550-kilometre high orbit. JAXA had been forced to scrub 3 earlier launch attempts due to bad weather. The new orbiting observatory will spend the next month checking systems and calibrating instruments before beginning a 3-year scientific mission. Once operational, XRISM will study some of the hottest objects in the universe, such as neutron stars, black holes as they're feeding, and massive galaxy clusters. XRISM's principal investigator, Richard Kelly from NASA's Goddard Space Flight Center in Greenbelt, Maryland, says the spacecraft will also examine the aftermath of stellar explosions, and it will examine near speed-of-light particle jets being launched from supermassive black holes at the centers of galaxies. XRISM will detect X-rays with energies ranging from 400 to 12,000 electron volts. Now, by comparison, the energy of visible light is around 2 to 3 electron volts. The electron volt range selected by scientists will provide astrophysicists with new information about some of the universe's hottest regions, some of its largest structures, and objects with the strongest gravity. The mission has 2 principal instruments, Resolve and Extend. Resolve is a microcalorimeter spectrometer developed in collaboration between NASA and JAXA. When an X-ray photon hits Resolve's 6x6 pixel detector, its energy will cause a slight increase in temperature. By measuring each individual X-ray's energy, the instrument provides information about its source, such as its composition, its motion, and its physical state. But to detect these tiny temperature changes, Resolve needs to operate at just a fraction of a degree above absolute zero, minus 273.15 degrees Celsius. To get that cold, Resolve is equipped with a multi-stage mechanical cooling processor mounted inside a refrigerator-sized container of liquid helium. XRISM's second instrument, Extend, is an imager developed by JAXA to give the spacecraft one of the largest fields of view of any X-ray imaging satellite ever flown. It'll be able to observe an area about 60% larger than the average apparent size of the Moon, and the images it collects will complement the data being collected by Resolve. Each instrument is mounted at the focus of its own X-ray mirror assembly designed and developed by Goddard. See, the thing is, X-ray wavelengths are so short, they pass straight between the atoms of dish-shaped mirrors used to capture visible infrared and ultraviolet light. So to overcome these issues, X-ray astronomers use nested curved mirrors turned on their sides. When X-ray photons hit these mirrors, they'll skip off the surfaces and into the detectors, just like a stone skipping across the surface of a pond. Each of XRISM's 2 mirrors houses hundreds of concentric, precisely shaped aluminum shells built in quadrants and assembled into a circle. In all, there are over 3,200 individual mirror segments in the 2 mirror assemblies. Also aboard the H-2A rocket for the launch was JAXA's Smart Lander for investigating the Moon, or SLIM spacecraft. SLIM is designed to demonstrate new accurate pinpoint lunar landing techniques. NASA provided the laser retroreflector array used by SLIM as both agencies cooperate in the international effort to further explore the Moon and ultimately human exploration of Mars. This report from NASA TV.
So X-rays really shows us that the universe is very energetic.
We find X-rays in jets, erupting from the centers of active galaxies. We use them to measure the spin of black holes or supernova explosions. It takes a powerful event to produce cosmic X-rays.
Sometimes people also call it the hot universe because, when you have this gas in galaxy clusters or also around galaxies that you can see only in X-rays, this gas is about 10 million to 100 million of degrees, which is so hot that this gas does not radiate in optical, does not radiate in infrared, but it only radiates in X-rays.
To further understand these hottest regions, we need the next generation X-ray telescope. The Japan Aerospace Exploration Agency, or JAXA, is partnering with NASA and the European Space Agency to launch the next generation X-ray space telescope. The telescope, called XRISM, weighs over 5,000 pounds, stands over 30 feet tall, and will orbit approximately 340 miles above Earth. We're familiar with the medical uses of X-rays. X-ray light is energetic enough to pass through our skin. Our calcium-dense bones absorb that light, blocking it from reaching the detector and creating a shadow. Luckily for us, X-rays from space don't make it through our atmosphere. But what that does mean is that we have to send X-ray hunting missions into orbit to detect this high-energy light. XRISM also needs special kinds of mirrors, which were built at NASA's Goddard Space Flight Center.
The type of the mirror is called a nested mirror. It looks like a cross-section of the onions.
X-rays are so energetic they fly right through typical mirrors.
For the visible light, we typically place the mirror so that light just bounces back. But for the X-rays, this doesn't work, so that we put the mirror so that X-rays just graze surface of the shell.
When they strike mirrors at very shallow angles, X-rays too can bounce.
And then so we made it like a conical shell, then X-ray can be directed.
XRISM has 2 instruments, each with their own mirror assembly. One for imaging, called Extend, the other for spectroscopy, called Resolve. JAXA built Extend to provide XRISM with a wide field of view. It can observe an area about 60% larger than the average apparent size of the full moon. NASA's Resolve instrument is a spectrometer that splits X-ray light, like a prism, so scientists can detect specific elements present in the sources they're studying. It uses a small 6x6 pixel detector called a microcalorimeter, nestled in a refrigerator-sized container of liquid helium. Resolve will measure the small temperature changes caused when X-rays hit one of those pixels. To track such small temperature changes, Resolve's detectors must be kept extremely cold. That liquid helium cryocooler will keep the instrument at 0.05 degrees Kelvin. It's so cold, it is a fraction of a degree above absolute zero. Heat is simply a product of moving atoms. Keeping Resolve's detector that cold means that the atoms barely move. So there's very little thermal noise in the system. It's what keeps these accurate measurements possible. Each X-ray detected will help scientists pursue many questions about the hottest regions of the cosmos. What's happening in the extreme gravitational fields around black holes? Can we discover what is inside a neutron star? How did some of the universe's largest structures, like galaxy clusters, evolve?
Optical telescope, you will just see galaxies everywhere. If you look at this same cluster of galaxies in X-rays, you will see actually a lot of gas. And this gas, it constitutes actually most of the matter, the cluster of the galaxies, which is something extremely important to understand, because it means that most of the matter in the universe is not in the form of planets or stars, but it's really in the form of this gas. But CRISM really has this capability of decomposing this X-ray light in a way that's much, much more accurate than what has ever been done before.
And in that report from NASA TV, we heard from NASA CRISM mission astrophysicist Francis Maria and Takashi Okajima. This is SpaceTime. Still to come, discovery of a local baryonic acoustic oscillation. And later in the science report, Australia on course for increasingly hot and dry conditions. All that and more still to come on SpaceTime.
Littleton Coin Company is ringing in the holiday season with daily deals. Visit littletoncoin.com for at least 15% off select products now through November 28th. Save on your favorite coins, such as Morgan Silver Dollars, Kennedy Half Dollars, commemorative quarters, and much more. But hurry, each day offers a new deal you don't want to miss. Visit us now at littletoncoin.com. That's littletoncoin.com. Littleton Coin Company, serving collectors since 1945.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Astronomers have discovered an immense bubble 820 million light years from Earth that's believed to be a fossil-like remnant of the birth of the universe. The bubble is thought to be the remains of a baryonic acoustic oscillation, a pressure wave or fluctuation in the density of visible baryonic, that is, normal matter, caused by acoustic density waves in the primordial plasma of the early universe. In the same way that Type 1a supernova provide a standard candle for astronomical distance, baryonic acoustic oscillations are overdensities of matter such as galaxies and galaxy clusters, and they're at set distances just like standard candles or standard rulers, but this time on the scale of cosmology. The length of this standard ruler is given by the maximum distance acoustic waves could travel in the primordial plasma before the plasma cooled to a point where it became neutral atoms. That's the time of the epoch of recombination, which stopped the expansion of the plasma density waves, freezing them into place. The length of this standard ruler is about 490 million light years in today's universe, and it can be measured by looking at the large-scale structure of matter using astronomical surveys. Current Big Bang theory tells us that during the first 380,000 years of existence, since the universe came into being 13.8 billion years ago, it was a cauldron of hot quark-gluon plasma, and within this plasma, electrons were separated from atomic nuclei. Now, during this period, regions with slightly higher densities began to collapse under gravity, even as the intense bath of radiation was still attempting to push matter apart. This struggle between gravity and radiation made the plasma oscillate or ripple and spread outwards. The very largest ripples in the early universe depend on the distance a sound wave could travel. Set by the speed of sound in the plasma, this distance was the 490 million light years we mentioned earlier, and it became fixed in place once the universe cooled and stopped being a plasma, leaving vast three-dimensional ripples in its wake. Then, throughout the eons of the universe's existence, galaxies and galaxy clusters formed in the density peaks of these enormous bubble-like structures. The remnants of this plasma, now cooled down to just 2.7 degrees above absolute zero, can still be seen across the universe as the cosmic microwave background radiation. You probably know it best as the faint white noise hiss you get between stations on old analog radio and TV sets. The new structure, reported in the Astrophysical Journal, has been named Ho'olilana, a term drawn from an Hawaiian creation chant involving the origins of structure. The study's lead author, Brent Tully from the University of Hawaii, says he unexpectedly found the bubble while studying a web of galaxies. He says his team weren't looking for it, but it was so huge that it spilled into the edges of the sector of the sky that they were analysing, and that piqued their interest. As an enhancement in the density of galaxies, it turns out this bubble's a much stronger feature than expected. The very large diameter of 1 billion light years is beyond theoretical expectations. If its formation and evolution are in accordance with theory, then this baryonic acoustic oscillation is closer than anticipated. That implies a higher value for the expansion rate of the universe. Astronomers located the bubble using data from the Cosmic Flows 4 experiment, which is, to date, the largest compilation of precise distances to galaxies. Tully co-published a catalogue last year, and this may be the first time astronomers have identified an individual structure associated with a baryonic acoustic oscillation. The discovery could help scientists bolster their knowledge on the effects of galaxy evolution. The same team of researchers also identified the Laniakea galaxy supercluster back in 2014. That structure, which includes our own Milky Way galaxy on its outskirts, is small in comparison. Stretching at a diameter of about 500 million light years, Laniakea extends to the near edge of this much larger bubble. Tully's team discovered that Ho'olilana had already been noted in a 2016 research paper as the most prominent of several shell-like structures seen in the Sloan Digital All-Sky Survey. However, the earlier work did not reveal the full extent of the structure, and that team didn't conclude what they had found was a baryonic acoustic oscillation. Using the Cosmic Flows 4 catalogue, the authors were able to see a full spherical shell of galaxies, identify its centre, and show that there really is a statistical enhancement in the density of galaxies in all directions from that centre. Ho'olilana encompasses many well-known structures previously found by astronomers, such as the Harvard-Smithsonian Great Wall containing the Coma Cluster, the Hercules Cluster, and the Sloan Great Wall. The Boötes Supercluster resides at its centre. Computer simulations have demonstrated that the shell structure identified as Ho'olilana has less than a 1% probability of being a statistical accident. Ho'olilana has all the properties of a theoretically anticipated baryonic acoustic oscillation, including the prominence of a rich supercluster at its centre. However, it does stand out stronger than expected. Also, Ho'olilana is slightly larger than anticipated based on the theory of the Standard Model of Cosmology. But the size is in accord with observations of the local expansion rate of the universe and of galaxy flows on large scales that also hint at subtle problems with the Standard Model. This is SpaceTime.
Wells Fargo presents one of the surest ways to grow your money. a Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
With no fees or minimums and no overdraft fees, banking with Capital One is the easiest decision in the history of decisions. Even easier than choosing to keep the Grinch away from the toy drive.
Who's going to deliver the toys to the kids?
What about me, the Grinch?
No.
Yep, even easier than that.
You steal the presents one time.
With no fees or minimums and no overdraft fees, is it even a decision? That's banking reimagined. What's in your wallet?
Terms apply. Capital One N.A. member FDIC. Copyright Dr. Seuss Enterprises. Copyright Turner Entertainment Company.
And time now to take a brief look at some of the other stories making news in science this week with the Science Report. A new study has found a worrying change in the Indian Ocean surface temperatures, which are putting Southeast Australia on course for what are expected to be increasingly hot and dry conditions. The Indian Ocean dipole was found to be a major contributor to the severe drought and record hot temperatures seen across Australia last year. The event, known as a positive Indian Ocean dipole, cut off one of the major sources for southern Australia's winter and spring rains. It also set up the extremely hot and dry conditions which promoted the Black Summer bushfires of 2019 and 2020. The new research, reported in the journal Nature, reveals that these historically rare events have become far more frequent and intense over the past century. And this situation is expected to continue to worsen if greenhouse gas emissions continue to rise. To reach their conclusions, scientists used coral records from the eastern equatorial Indian Ocean to reconstruct Indian Ocean dipole variability over the last millennium with unprecedented precision. And the authors found that historically strong events like last year were incredibly rare. In fact, since the year 1240, scientists could identify only 10 of these extreme events. But 4 of those 10 took place in the last 60 years. The research also showed that a persistent tight coupling has existed between the variability of the Indian Ocean dipole and the El Niño Southern Oscillation in the Pacific Ocean during the last millennium. While the Indian Ocean dipole and El Niño events can occur independently, periods of large year-to-year swings in the Indian Ocean variability also heightened El Niño Southern Oscillation variability across in the Pacific. Scientists have shown how the Black Death made the human immune system what it is today. Infectious diseases are one of the strongest drivers of human evolution, and a pandemic can cause the genes involved in immune responses to evolve rapidly. The study, reported in the journal Nature, analysed ancient DNA samples from 516 individuals, all of whom died about the time of the Black Death in the 14th century. They identified 245 genetic variants that were all very different when comparing pre- and post-Black Death samples. The variants associated with protection from Black Death bacterium overlapped with genes associated with increased susceptibility to autoimmune diseases. The authors say this highlights the contribution of natural selection of present-day susceptibility towards chronic inflammatory and autoimmune diseases. The Black Death is considered the deadliest plague to be recorded in human history, causing the deaths of somewhere between 75 million and 200 million people. The pestilence was a bubonic plague pandemic which infected Western Eurasia countries as well as Northern Africa between 1346 and 1353. The Black Death is estimated to have killed between 30 and 60% of the European population, as well as a third of the population of the Middle East. It's caused by the bacterium Yersinia pestis, which is spread by fleas. But it can also take a secondary form, or it's spread through person-to-person contact by aerosols, causing pneumonic plagues. The plague created religious, social and economic upheavals, with profound effects on the course of European history. The pandemic's thought to have originated either from Central or Eastern Asia, but its first definitive appearance was in the Crimea in 1347. From Crimea, it was most likely carried by fleas living on black rats. these travelled on Genoese trading ships, spreading throughout the Mediterranean basin and reaching North Africa, Western Asia, and the rest of Europe through Constantinople, Sicily, and the Italian peninsula. There's evidence that once it came ashore, Black Death quickly spread person to person as a pneumonic plague. And of course, it wasn't just a single event. There were further outbreaks throughout the later Middle Ages, even continuing right through to the early 19th century. Symptoms of the Black Death include fever, headaches, painful aching joints, nausea with vomiting, a general feeling of malaise, and the appearance of buboes in the groin, neck and armpits, which oozed pus and bled when opened. Left untreated, 80% of those who contracted bubonic plague would die within 8 days. Scientists have found that baleen whales around the coast of California are estimated to ingest up to 10 million pieces of microplastics every day. The findings, reported in the journal Nature Communications, combine microplastic data from the California current with high-resolution foraging behaviour measurements from 191 tagged baleen whales, including blue, fin and humpback whales. They found that baleen whales mainly fed at depths of 50 to 250 metres, and that just happens to be where most microplastics are found. Now, based on their measurements, the authors estimate that blue whales could consume up to 10 million microplastic pieces every day, while humpback whales will still be consuming around 4 million pieces daily. The findings suggest that baleen whales may consume the most plastic of any organisms, and that microplastics could pose a far greater risk to these whales than previously thought. There's growing concern in the international community about the honesty and trustworthiness of the World Health Organization. The world's most powerful health authority recently celebrated its 75th birthday. The WHO was originally set up by the United Nations to fight global diseases and provide medical treatments to underdeveloped and third world countries. But according to the medical fraternity, the WHO appears to have lost its way in recent years. It's been pushing dangerous pseudoscientific treatments, including alternative medicine practices such as naturopathy, traditional Chinese medicines, homeopathy, and Ayurvedic treatments. The situation grew worse after Tedros, a former guerrilla in Ethiopia's Socialist Tigray People's Liberation Front, became WHO Director General with the backing of the Chinese government. Then, in 2017, Tedros appointed Zimbabwe's ousted socialist president Robert Mugabe to serve as a WHO Goodwill Ambassador. Mugabe, a self-described Marxist-Leninist, had by this stage been accused by the European Union, the United Nations Security Council, the Human Rights Watch, and the Zimbabwe Council of Churches of being a dictator and responsible for economic mismanagement and widespread corruption, as well as human rights abuses, including anti-white racism and crimes against humanity. It was also under Tedros in 2020 that the WHO ignored warnings from frontline doctors about a fast-spreading new pandemic in China, which later became known as COVID-19. This failure to respond gave the deadly virus the time it needed to quickly spread globally, killing an estimated 18 million people so far. Tim Mendham from Australian Skeptics says, now instead of focusing on the provision of medical care to those who need it, the WHO is again promoting dangerous pseudoscientific treatments.
In most cases, the WHO has done a great job. It's been so instrumental in treating sort of diseases around the world, especially in third world countries, with vaccination and that sort of thing. So it's a very important body. So to see it going in certain directions is a worry. And over the last decade or so, there have been signs, and it sort of started off with the promotion of traditional Chinese medicine, saying that this is a valid part of medicine and should be regarded as part of normal treatments, etc. So it's given the imprimatur of the WHO. There's so much in traditional Chinese medicine, which is frankly witch doctor stuff. Yeah, it's just magical thinking, pretending to be ancient medicine or something. But most of it's just sort of, I mean, yeah, you take some of the stuff that's in there and you develop it, and like you do with any sort of natural product, and you find the actual working product. But most of traditional medicine is based on very, very unscientific theories. Okay, that's one aspect. At the same time, it's been pushing naturopathy, which is definitely magical thinking about the spirit of the body helping you cure, etc., and that promotes a whole range of pseudosciences as well. And homeopathy, of all things. Now, homeopathy is junk. There's no other way of saying it. It can't work, it doesn't work, it shouldn't work, and it doesn't work. So, I mean, for the WHO to be pushing that. Now, there's a lot of conspiracy theories about it, the reasons why. The person who was running WHO for a while, she was pushing Chinese medicine. Other suggestions that China is a big funder of the WHO, so they're trying to placate a Chinese approach to medicine.
Well, we've certainly seen China's involvement in the administration of the WHO of late. I mean, the WHO refused to acknowledge the problems of COVID-19 until very late. It was one of its great failings, and that was brought about by pressure by the Chinese government.
Yeah, so we can probably say there's pressure from the Chinese government on a whole range of areas of medicine. I've spoken to a number of people in Australia who are concerned about influence on research activities, funding and control, and sort of pushing certain areas. For your info, I've had a Nobel Prize winner who said that to me. It's a concern, and the concern of where the WHO is heading by trying to be a bit too inclusive. Now, the reasons for that was up to everybody to figure out, but certainly the very fact of actually endorsing and saying that these things are valid when they're not, and coming from such an august body, is a real worry. And it's an ongoing worry, and we have been sort of mentioning it ourselves, but so is the world, basically, that is very concerned about this.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.